Okay, I'm looking at some Unit 2 revision questions for maths methods, starting off with some on logs and exponentials. So our first one we've got here is we are wanting to solve for x. So we've got 2 to the power of x is equal to 64. Now, when I see that, I know I want something with a base of 2 for 64. Now, I know that that is 2 to the power of 6. So I can then equate the indices and write x is equal to 6. Now, if you weren't sure, you might want to try some values to put in there to see what you would get to get 64. Your other option is to use your logs. So to go instead and write log 2 to the x is equal to log 64. Bring that x down the front. Log 2 is equal to log 64. And then to get the x on its own, you do log of 64 over log of 2. And do that on your calculator and you would get 6. Obviously, doing the powers of 2 is your quicker option. The next one we've got log base 10x plus 2 log base 10 5 is equal to log base 10 6. So what we want to do is use some of our log laws first. Now, when there's a 2 in front, we want to make that a power of 2. So take that back up to the top and get 5 squared. And then once we've done that, we can bring them together. So we know when we are adding logs, that's where we'll multiply what is inside. So we've got log 10, and then that would give us x times 25, or log 10 25x, and that equals log 10 6. So now that we've got that, we can see that 25x must be equal to 6 because we've got that equivalency there. We know that they're equal, so we can say that that is equal to that. And so then we can say that 25x is equal to 6. Therefore, x is equal to 6 over 25. The next one we've got a base 3, but we've got an a and an x. So we want to solve for x was the instruction for this question. So we're going to work on getting the x on its own. So starting the same way, we're going to bring that 2 up the top. So we get log 3x squared plus log 3a is equal to 0. Then we know we can multiply. So we would have ax squared when we did multiply those two parts is equal to 0. Now, to get a 0, we know that we must have had log 3 1 to give 0 because 3 to the power of 0 is equal to 1. So that means we can then say that this section here must be equal to 1. So ax squared must equal to 1. So x squared must be 1 on a because we're trying to get what x is equal to. So it's obviously going to be in terms of a. So then x is going to be the square root of 1 over a. Now the next question we have is 27 to the power of 4 over 3. Now, you might want to go straight to your calculator and just type that in. With this question, it will often be listed as maybe tech-free, or we're assuming that you're going to show us your understanding of powers. When I see that 3 on the bottom of the fraction, I'm hoping that I can write something to the power of 3 to mean that I can simplify that a little bit more easily. When I see 27, I know it's going to have a base 3, and I also know that that is 3 to the power of 3. So 3 squared is 9, 9 times 3 is 27. So I'm going to write that and put my fraction outside. Then I know using my index laws that I will multiply those together. So 3 times 4 on 3, I know is going to leave me with 4, and that's the beauty of having that 3 there. Now I've got 3 to the power of 4. I can then work that out. What my 3 to the power of 4 is going to be equal to, and just checking they haven't said to leave in index form. So if they'd said to leave in index form, you'll just leave as 3 to the power of 4. Otherwise, you can write the 81. The next one we have is question 3. So we've got, our question has 3 log base 2 of x minus 1 is equal to log base 2 of 27. So first step, like we've done before, when that 3 is at the front, we're going to take that and put it up the top. So we get x minus 1 cubed, log 2, 27. Now that we've got the same base there, we can then say that this part must be equal to that. So we can write x minus 1 cubed must be equal to 27. And then we can say that 27, we've already talked about before, is 3 to the power of 3. So we have x minus 1 to the power of 3 is equal to 3 to the power of 3. Therefore, the x minus 1 must be equal to 3. So then we can say that x must be equal to 4.